Hey guys, this is 17B. I left this little persistence of different chemicals in the environment off the last one on accident, but it's just as important for this one. Go ahead and take a look at some of the things here. And they're talking about half-lives. They're talking about the amount of material still left in the soil, just like with nuclear waste. And look here, there's some reasons why. Figuring out what things are, maybe having more of a precautionary measure of risk assessment versus innocent until proven guilty, why it might matter, right? Because look at things like DDT that take 30 years to decrease their percentage by half, right? Some things are just a matter of days, right? Like phthalates, like in the movie Baggett. Yeah, like in that movie Baggett, they showed that it can go away pretty quickly, but you need to know, right? You need to know. And so that kind of brings us into the chapter opener, the Bucket Brigade people. Yeah, so the Bucket Brigade people in Norco decided that even though they weren't scientists, even though they weren't environmental scientists, that they would take scientific education into their own hands so that they could learn about what was happening in their environment, right? So they would take these buckets and put bags in them, and what they would do is they would do the grab bag approach, where they would grab some of the air out of the bag. They would send it off to like a facility and get it tested. Right, and this is kind of how the mechanism works a little bit. Right, so air goes in. Right, air goes in, and then they're able to pump it into something that they can test the air. Right, and they would have like a sniff test. They'd have people like community awareness. If somebody smelled something funny, they would take a test of the air there. And so what that tells you is that you don't need to be a scientist to get involved in risk assessment of your community, right, and upkeeping your community and making it safe for everyone. And this is also why you're in a class like environmental science, even if you're not going to be an environmental scientist or even a science major, you live on this world, right? Just like in Lord of the Rings, when the little hobbits are trying to convince the tree ants like why they should care, right? Like, you live in this world, right? All right, so let's look at risk analysis. Okay, we're going to look at acceptance, right, and how much can be tolerated. And we're going to look at the balancing of environmental and economic factors. We're going to look at the innocent until proven guilty, and the precautionary principle. All right, so let's go ahead and take a look at the risk assessment and how it eliminates possible harm. So first off, let's define what an environmental hazard is. Anything in the environment that can potentially be a harm, whether it be biological, chemical, or physical, right, like a weather event or something. All right, so an assessment, obviously you are identifying, you characterize it, you look at the LD50, ED50, and you determine the extent of exposure, like how much people have been exposed. All right, in risk acceptance, you're going to determine the acceptable level of risk. So sometimes it's not practical to want 0% because it might be at odds with the way that everybody lives, right? So if you live in a coal mining community and you want 0% SOx in the air, or you want 0% mercury given off or lead given off, then everybody who lives in that community won't be able to make a living. They won't be able to eat. They'll have to move out of the community, right? So you have to have some level that makes sense for your community. And then finally, at the end, risk management is determine the policy with input from private citizens, industry, and interest groups, right? So this is like the new age kind of everybody wins sort of ecological action here. But what's really, really important about risk acceptance is what I was telling you just now, and make sure that you understand that you need to have some idea of what you allow your community to live with, so that you can move forward and plan the appropriate risk management. So this is a really interesting graph here. This kind of gets into the actual chances and probabilities that you will die or become involved in one of these actions, these risks here. And this gets into our idea of qualitative versus quantitative. I'm just going to put quantitative, like quantity, right? And this one right here in economics would kind of be more like normative, where it's like what ought to be, what should be, what you feel, like what's your feelsies in your heart. So most of us think that, it's super dangerous to fly a plane because you can die in a plane, right? Well, if you look at the percent probability of a plane, it's 1 in about 7,000, which is really, really, really small. But then you look here at motor vehicle, on your way to the airport, you're much more likely to die. If you don't take care of yourself, you're much more likely to die from some sort of cardiovascular, from cancer, from different things in the environment. 1 in 7 people will die from cancer at some point in their lives. And heart disease, even greater, right? So if we really took more of the quantitative approach to risk assessment, we would do much more to prevent things like heart disease, cancer, stroke, and motor vehicle accidents, right? So it's kind of interesting to think about it like that, right? So that's the qualitative. It's like, oh, well, I've seen people drown in a pool, or I've heard of people drowning in a pool, or somebody getting hit on a bike, or things like that. So let's do something about these things, right? But if you look down here, right, this is something that you probably want to do something about, right? So you want to do something about these things, right? Now, falling, I'm not sure what you could do about that. I know that older people, they tend to fall, and when they do fall and do things like break their hip, they have like a 1 in 3 chance of passing away within the next year, right? So it's a really big deal, falling, right? So what can we do to prevent things like that? All right, so again, these are just the definitions of quantitative and qualitative. And because our personal risk assessments are not quantitative, or they don't look at the actual numbers and data, they often do not match the actual risk, right? So we're more afraid of things that we shouldn't be, right? I had a college professor tell me, like, you know, when I decided to get a bunch of my plane tickets was right after some sort of travel scare, right? Because what are the chances that that thing's going to happen again the very next day? Which is kind of a grim way of looking at it, but you know, he was ultimately right. All right. So again, so what is a risk? You can kind of think mentally the probability of being exposed to that hazard times the probability of being harmed if exposed. So that goes back to that chart with the 1 in 700, 1 in 300. So it's like if you are to be exposed to it, right? So if I live somewhere that's made out of guns, which shouldn't be too hard, right? Your probability goes up, right? And then if you're in an area with a lot of aggravated assaults and aggravated robberies, armed robberies, then your probability of being harmed if exposed is great. And plus, you know, a bullet only knows how to shoot, right? It doesn't know how to unshoot. Once it's fired out of the gun, it doesn't know how to stop. So if you are exposed to that, it is mostly lethal, right? Risk acceptance is how much is tolerable. Some people are not willing to live with the risk and others are not, right? Even among those people who are willing, the precise amount of acceptance is open and disagreed upon. Environmental scientists, economists, and others can help us weigh options as objectively as possible by providing accurate estimates of cost and benefits. So you have to do a lot of cost-benefit analysis. Just think about some of the things you had to consider and weigh when you were doing waste management, right? Incineration, cradle-to-grave tracking of goods, source materials, just kind of looking at how to get rid of it. Do I use an incinerator? Do I use a landfill? Do I recycle? And if I do recycle, do I recycle glass? Do I recycle aluminum? Do I recycle paper? Do I recycle plastic? So all those things have to be weighed, pros and cons. The exact same thing is true for risk, and that's kind of scary a little bit, right? But that's the reality. Right? We live in an imperfect world with lots of sharp, pointy edges, and we have to decide. Do I want to get killed by this? If not, how much, right? And we make plans accordingly. All right. So here are the two philosophies to acceptable amounts of risk and how much risk we're going to allow to persist in the first place. So in America, we have the innocent until proven guilty, where you literally have to prove that something is harmful before you can take it off. Okay? And it has to be scientific. Okay? So it has to be harmful, and then you'll take a consumer product off the shelf. All right? In Europe and a lot of other countries in the world, they use the precautionary principle, which as soon as something has a plausible environmental hazard, they will take it away, and then you have to prove that it is, again, safe. This one you have to prove that it harms. This one you have to prove that it's safe if you suspect anything. So what are the pros and cons of this, right? So with precautionary, obviously there's human health benefits, right? There's public health safety, that is increased because you are being very precautionary, right? You're waiting to see that this thing is safe before you're allowing it to affect the public. Innocent until proven guilty. It does leave your society open to a little bit more public health problems, but it is much better if you're a businessman or a businesswoman, because your product is out there for longer, right? So you're able to make better profit. With precautionary principle, if your product is found to be safe ultimately, then of course you lost out on all of that profit. So that is kind of the downside of that, right? So economic is the pro, economic is the con for this one, for precautionary. Public health safety is the con for this one, because you are not keeping the public as first priority. In the precautionary principle, public health is your priority, so that's the pro for this one. All right, so here's a flow chart of that. You can go ahead and take a look at this, pause it if you need to. All right, and then Stockholm Convention. An agreement among 127 nations concerning 12 chemicals to be banned, phased out, or reduced. And REACH is an agreement among the nations. It's an acronym that stands for registration, evaluation, authorization, and restriction of chemicals. So make sure you know this one. Make sure you know this one. It basically goes into our risk management. It goes into our risk management. All right, so that's 17B. Study that. Good luck.